Hello, everybody. We're going to do a warm up first. So I would like you to do number one, which is a piecewise function on your own, and pause the video. And then you can fast forward to the end of where you think it might be and see if you're right. And if not, then watch it. All right. So pause the video now and complete the warm up one. Okay. So the first thing that I'm going to do is start by graphing negative x plus 4, plug in 0. I get 4, it's less than or equal to 0, so I made that 0 closed. I'll try negative 1, and I get 5. So 0, 4, negative 1, 5, and I have to graph to the left because my fence is at 0. Okay, then I'm going to graph x squared minus 5. 0 will be open, 3 will be closed. We plug in. And we graph. And that's in between the fences of 0 and 3. And then finally, it's just going to be 2 for everything greater than 3. So at 3, comma 2, there's an open circle, and then the graph goes to the right. All right, so that's what that graph looks like. The next thing I want you to do is I want you to come up with a piecewise function. So you might not find this to be that easy, but at least you should be able to find the x's. So let's just kind of look at where our fences are. I've got one here and I've got one here. So my first graph is going to be everything less than or equal to negative 1 because I'm starting with this point. Then the next part is going to be from negative 1 open circle to 1. And that's this piece here. And then the third part is going to be x greater than or equal to 1. So now I have to come up with the y values. Well, these are just lines. So if I think of this first line as having a slope of up 1 over 1, I know that the equation is going to be 1x plus my y-intercept, which if I continued, I could see would be 2. Okay, I'm just going to erase stuff from here so it's not confusing. Now, for the next part between negative 1 and 1, that little piece right here, I can see that my y-intercept is 1, 1, 2, 3, but my slope is again 1. So it's x plus 3. And then for the last one, I can see if I extend this, my y-intercept would be 1, and again, the slope is 1. So now this is x plus 1. So that's how you can come up with an equation for a piecewise. Hopefully what you noticed on Desmos is how anything that's being done on the inside of the function happens to x in an opposite way, and anything on the outside of the function happens to y in the same way. So for example, if you have something like y equals, let's just say 2 times a function, and maybe we'll put 3x minus 1. I like to box the equation, the function itself, and then anything that's on the inside. So let me just get a highlighter here like that. Inside of the function affects x opposite. So in other words, all x's will be divided by 3. But then anything that's on the outside of the function, so let me get a highlighter here, happens to y in the exact same way. So all y values will be multiplied by 2 and subtracted by 1. So what does that mean exactly? Well, if the x's are being divided by 3, that's something that's affecting horizontally because it's x, and it's a horizontal shrink of a third because it's being divided by 3. Whereas with the y's, this 2, it means that there's going to be a vertical stretch of 2. And then this -1 means that the function is going to move down 1. Okay, so let's see what you think is going to happen to the graph of f of x when it's now in this situation. So why don't you just pause the video for a second and see what you think. Write it down. Okay, so what I see is I can highlight the inside, and that's what's going to happen to x oppositely. So all x's will be subtracted by 1. Whereas with the y values, if you look on the outside, so like if I box that function in, that's what's happening to x, but everything else is happening to the y. So all y's get multiplied by 3. And subtracted by 2. Okay, I didn't realize that the next one's kind of similar to the one I did before, but for this next one, it's the same idea. Oh, sorry. Let me highlight. Okay, so that's all what's happening to the inside of the function, and then this is what's happening to the outside right here. Okay, so all x's are being divided by 3. So just keep in mind that means it's a horizontal shrink of a third. And all y's are multiplied or divided. I was going to say multiplied by 1/2 or divided by 2. So it doesn't really matter which way you want to say. Multiplied by 1/2. So let's say then that's going to be a vertical shrink of 1/2. Okay, so let's go to the next page. Okay, so here's how it's going to work. It's going to be pretty simple. It's no longer just any old f of x. It's actually one of the parent functions. So you first want to figure out what is the parent function. And in order to get the parent function, the idea is you kind of get rid of all of the numbers. So let's get rid of all of the numbers, not the exponent. And you can see that x squared is the parent function. Okay, so I'm going to write down at the bottom here that my parent function is y equals x squared. And the question is, what's the rule? So what I write for the rule is I'm going to say that the normal xy coordinate goes to a new point. So what is this new point? Well, all my x's are going to be added by 2. And then for the y's, I'm going to look on the outside and do the same thing. So you kind of think of this as like being a big Y. So all my y's are getting multiplied by 3 and subtracted by 1. Okay, so now's the time where we're going to start plugging in points. So we're going to do the parent function like we did in the last section. We're going to square all of the values. And then what's going to go on the outsides is going to be the rule. So I just took it from here. So now if I look here, all I'm doing is I'm going to plug x in for each of these. So I'm going to add 2 to every x, basically. And that's going to shift all the graph, can't talk and write at the same time, to the right. Then I'm going to plug in all the y values. So 12. So you can see all the y's are getting multiplied by 3. They're getting vertically stretched and then move down 1. So I get 11. I think that's 2. -1. And then you get the same thing. And now you don't graph the middle, you only graph the outsides. So 0, 11, 1, 2, 2, -1, 3, 2, and 4, 11. So you can see the symmetry here and how this gave us the perfect points, okay? So that's the idea. All right, so let's try this next one. Okay, so you can think about what is a parent function here? Well, again, let's cross out all the numbers. You can see that it's just the square root of x. Okay, so that's going to be my parent. You can kind of put that right here. And then what's the rule? Well, every x and y goes to, now let's think about what's going to happen. It's going to be the opposite for the inside. So all the x's on the inside of the function are getting multiplied by -1/2, which means, or so they're really getting divided by -2, which means they're going to get multiplied by -2. So when I say opposite, the negative part stays negative. It's not the negative that's the opposite. It's more like the inverse function. Instead of dividing by half, I multiply by 2. And then to look at the outside, that's the only thing that's happening. So then I get that. Okay, now you got to think about the function. The numbers I plug into the square root function are 0, 1, 4, 9. I'm not going to do 16 because my graph isn't that big. And I plug them in here. And now all my x's get multiplied by -2. Oh, that's going to be too big as well. And then all my y's get subtracted by 2. Okay, so let's graph. So I have 0, -2. That's my starting point. -2, -1. And then -8, 0. And I'm not going to do the last one because I just can't. So this is what the graph looks like. Okay, so let's just stop for a second and think about what the negative on the inside did to this graph. What the negative did to the graph is it made all of the x's negative or opposite. You can see that all the x's became opposite. And so the negative on the inside actually flips the graph over the y-axis. Okay, so the negative, I should say, negative on the inside. So we've talked about what all the numbers do, but we didn't talk about what the negatives do. So the negative on the inside flips over the y-axis. And by the way, a negative on the outside is just going to flip over the x-axis. I may as well write that down here. A negative on the outside of the function flips the graph over the x-axis. And that's because if the negative is on the outside of that function, something like this, these are all y values. And then when your y values become negative, they flip over. Instead of being like this, they flip over the x-axis. Okay, so I think that's it for this page. All right, so I think this is a good time for you to pause the video and try on your own. Think about what your parent function is going to be and think about the rule and just do that alone. All right, so pause the video now and write down the parent and the rule. So you're dividing your x's by 2, and then for the y's, it's just what you see. And now there is a negative with the y, so this graph will flip over the x-axis. So there's a couple things that I could be asking you here. One is definitely to graph it, but the other one is what's going to happen to the graph. So let's actually talk about that first. Okay, so if I say to you in words, what's happening to the graph without you graphing it, you want to go in order of RST. I'll explain what those are in a second, but it's easy to remember because they're alphabetical. So let's first talk about the reflection. Okay, well, there's a y on the outside, or there's a negative on the outside, so it's going to reflect over the x-axis. S stands for shrink or stretch. So that's what we talk about next. Okay, so you always look at the rule when you're talking about any of these things in words, because when you look up at this 2x, you might be confused and think that it's a stretch, but the rule always tells the truth. So in this case, we have looking at x, a horizontal shrink of a half, and then a vertical shrink of a third. Notice I do not mention the negative. I already took care of that with the reflection. And finally, for the translation, the only thing happening here is that it's a shift. Oh, sorry, T stands for translation. And it's a shift up 1. So that's how you would say it in words. Okay, so the points we're going to be plugging in, -2 to 2. And let's write it on our rule. It's going to be kind of ugly with the -1/3. Plug it in. Plug it in. -2/3 plus 1, think that I hope I'm not making a mistake here. Let me know if I do. I think that's right. Okay, so -1, 1/3. -1/2, 2/3. Whoa. So it's up a little bit higher. It's terrible. 0, 1. Very, really awful graph. Sorry about that. 1/2, 2/3. And then 1, 1/3. So you can see it did in fact flip over the x-axis, and the shrinks and the shift up one. Okay, oh boy, so now now we have a cubic equation, and there is something different that we haven't seen before, and that's where we have a binomial on the inside and a negative here. And so something different is going to have to happen. You might think that this is actually a shift to the right 3 because we do opposite, but you have to consider factoring the negative out first. And this is truly what's happening with the graph. So it's actually moving left 3. So that's the big thing that you have to remember here, is that if you have a negative, you have to first factor it out before you start your rule. Okay, so in this case, my parent function is the cubed root of x. And then the rule is going to be, sorry, that's actually not right yet. So what's happening is all my x's are getting multiplied by a -1, which essentially means that they're being divided by a -1, and then they're being subtracted by 3. So that's just -x minus 3, and then nothing's happening to the y. Now you might notice that these are the same. The only time the x rule is the same as the x equation is when there's a negative in front. It's almost like a double negative. So one little trick, if you are into, learning some tricks, is that whenever there's a negative on the inside, the rule actually ends up being exactly the same. Otherwise, just factor it out and then know that your x's are being divided by this -1. And so we do that and then subtracted by 3. Okay, so now my parent function, the numbers we plugged into the cubed root are these. And I have nothing more for the y, so now I just plug that in. I believe that's 5, -2, -3, -4, -11. When you graph this, remember, don't just graph blindly. Think about the fact you're just graphing the outsides. Think about the fact that it should look like a particular shape that you're used to. So 5, -2, -2, -1, -3, 0, -4, 1, and -11, 2. Okay, so let's now connect these dots. Okay, and you can see it's the cubed root function, and it has been reflected over, let's think about which axis. Because the negative is in with the x, it's going to be a reflection over the y-axis. That's a little shortcut for that. And it's been shifted left 3. All right, now something's different with the reciprocal function. So the notice I don't even have a chart. The parent function is 1 over x. The rule is, you can see that this is kind of considered to be like the inside of the function, is it's being moved 4 to the right, and then this is on the outside, so it's y plus 3. So instead of drawing graphs or plotting points, what we're going to do is we're going to just shift the asymptotes. So if you guys remember, the asymptotes were just like, the vertical and the horizontal line. So now the axis is being shifted 4 to the right. So that's going to be my new one. And the horizontal line is being shifted up 3. Okay, so that's y equals 3, x equals 4. And then I'm just going to quickly sketch the graph in quadrants 1 and 3. If there were a negative in front, then it would have been in the other 2 quadrants. Okay, and so here's a graph of a function. And the first question is, what would 2f of -x plus 3 minus 4 do to the point -6, -4? So what I want you to do first is think about what would this rule be. Okay, so if I box my function, and I can keep in mind that whenever the x is negative, the rule is exactly what you see. Or if you don't like that, factor the negative out, and then you can see that we have to divide x by -1 and add 3, and you still get this. So all you do is you just plug the point -6, -4 in. Okay, so that should be 9, right? I think. And then plug that one in. Doing a lot in my head. I hope that's right. And that would be how the point shifts. Okay, and then the last part of this question says, let's just sketch negative f of 1/2 x on top of this graph. So what I would do is I would first make the rule. Okay, so everybody make the rule here. You make the rule, pause the video for a second and see if you get it right. Okay, that's what I get. And so then what I would do is I would make a chart, and let's do all of the ordered pairs that I see in the graph. And all of your x's are getting multiplied by 2, and all of your y's are getting multiplied by -1 because they're going to reflect over the x-axis. So -12, -6, 0, 6, 12, 4, 0, -5, 0, 4. Okay, so -12, 4. These go by what? 2, 4, 6, 8. They go by 2s. Okay, so -12, 4. -6 is, what do these go by? All of them go by 2s. -6, 0. 0, 5. No, 0, -5. 6, 0. And 12, 4. And so really, can you see how it's stretched horizontally by 2 and flipped? Okay, very last thing. Finally, we are getting there. We are going to be finding equations, going backwards to find the equation. So we know that the parent function for this is y is equal to the absolute value of x. But you can see that normally the absolute value of x goes over 1, up 1, over 1, up 1. Looks like that. So there's definitely been a stretch. We're going to assume all stretches are vertical for these problems. And let's also notice that the point normally would be at 0, 0, and the point has been shifted 2 to the right and 1 up. So there's a couple things we need to do. The first thing we're going to do is I'm going to put an A on the outside, and that's because that's going to tell me what my vertical stretch is or shrink. And then on the inside, it's got to be that it shifted right 2, so it's going to be x minus 2 and then plus 1. Then I pick one point on the graph, but not the point that I plugged in, like the 2 and the 1. So this is the point 3, 4, is that right? 1, 2, yeah. And then you're going to plug that in for y. We get 4 equals, this is 1, so 1a plus 1, so a is 3, and then the final equation would be this. You might notice that the slope is 3, and yes, that does work for absolute value, doesn't work for every single graph. So let's try for this last one here. You need to know that this is the square root function, and this is the normal starting point, so this is how the graph has shifted. So you're going to start by putting an a in front, nothing happened to x, and a plus 1. And then we're going to pick a point on the graph that's not the 0, 1, so 2, -1, and plug in. Oh, this is ugly. Okay, subtract 1, divide by square root of 2, and we need to rationalize. The 2's cancel. So a is a negative, which makes sense because it does look like it flipped. So I get y equals negative square root of 2 for a, square root of x plus 1, which you can simplify and just rewrite like that because you can multiply insides of radicals together.